Okay, so the point of this video is going to be to go through um, Matt Estella's Joy of Vex lesson number 14. I want to be really explicit about uh, crediting um, CG Wiki, created by Matt Estella, who's a really awesome uh, member of the visual effects community. And so I don't want this video to be. I want to really acknowledge that this piggybacks off of a lot of the really hard work that he did to create this kind of learning Vex course. So I want to just explicitly say that this is the site that you want to go and I want to make sure I give all credit here. I'm just basically going to dive into the topics in kind of a video format, I guess, for this sort of thing. So I'm going to go over lesson 14, and we will kind of go pretty slowly through it and kind of explain as we go. So lesson 14 is all about kind of creating geometry, because up to this point we've been manipulating it, but of course there's going to be instances where it's useful to kind of add your own geometry. So I can, for example, go add point, and what's nice about Houdini is it will kind of pop up with this help stuff for you, or you can look up the documentation. Sometimes some people find this a little bit kind of challenging to read, so I'll show it in the help browser, but just for just to kind of start. So let's do that. So what the heck did we do? Well, first let me actually disable this and just kind of show that all I have is just a 5x5 grid, and then I'm just deleting the. I'm using the add node has this cool feature that says delete geometry but keep points, and in this case I really don't care about the polygons. I just kind of want to work with the points, so I did that to kind of make my life a little easier. But notice that in our geometry spreadsheet we have actually 25 points, right? Because we're starting at 0 and then ending at 24. So if we start from 0 and count all the way to 24, that's 25 points total. So now let's take a look here at the AddPoint function. So I'm going to open up help, and I'm going to find, oops, not do that, AddPoint, and let's see if we can find, here we go, Vex function AddPoint. So it says adds a point to the geometry. Now there's actually two different ways you can call the AddPoint function. First of all, we can see that it returns an integer, and then you can give it a geo handle, right? That's pretty common for a lot of Vex functions. The first argument is usually the geo handle, which again I've explained in previous videos. I've kind of used the term like geometry stream. So like this would be the geometry stream 0 because it goes into the 0 input. This would be stream 1 if we had something going into here, stream 2 and stream 3. So you know, most of the time if you don't know what to put for the geo handle, 0 is like a pretty good bet. There's only specific instances where you would want to do something other than 0. If you specifically want to access like the next geometry stream that's coming into the point, then you would do that. But for the most part, we'll usually be using 0 for the geometry handle. So we're saying, okay, this first geometry stream here, that's what I want you to add the points to, and then you can either give it a point number or a vector. If you give it a point number, it's going to basically make a new point with all the attributes and group memberships of the point with the given point number. So basically, if you have a point already that you just want to create some new versions of that, you can use that way, but most of the time we're going to be using this version where we're actually going to be uh, giving it a vector for the position. So I basically said, hey, go ahead and make a new point for geometry stream 0 and make it at 0, -3, 0. Okay, so if I turn this on, let's see, and then I display it, there's my point down there. So everything is good. We got our new point. So no need to worry, right? Well, actually there's something kind of going on here that might not be apparent right away. Um, but if I look at how many points, remember we had 25 points total before? Well, I have a lot more than 25. I've got actually 50 points now. So what the heck happened? I only wanted 1 point. Why did we get 50? Well, it goes back to that kind of fundamental concept that VEX works in parallel, meaning that I'm basically, this line of code right here is running for every single point that we had going into this node. It's going to run this line of code. So if we kind of step by step it basically, what happens is, this point says, okay, you want me to add a point to my stream and put it here. Okay, I did it, good. And then this point does the same thing. It says, hey, you want me to add a point at this position? Sure, no problem, I can do that. And then this point does the same thing, and pretty soon all of these points made a new point at this position. And so since we have 25 points here, we basically have 25 new points at that position. So that can be a little confusing kind of right off the bat. So how can we make sure that we only have 1 point there? Well, there's a couple ways we could do it. We could do a fuse sop at the end, and then go ahead and fuse all these points. So now if you look here, we only have 26 points, the 0 to 24 plus the new one. And basically what it did was it took all those points and it collapsed them down into one using this snap distance tolerance here. But if you think about it, that's pretty inefficient because we just created all these new points for no reason and then collapsed them down. So maybe on a piece of geometry with not a lot of points, that's not a big deal, but if we're dealing with thousands, maybe even millions of points, that's creating a lot of extra points for no reason. So a better solution would be, if I want to create a point at this specific, space right here, what I could do is I could say, there's lots of different ways you could approach it. One way is you could say, hey, if your point number is equal to 0, then go ahead and run this code. So you could do it like this. And the reason this works is because it basically says, hey, basically, remember, this code, each point is running it, right? So if I turn on point numbers, here's point number 0 right here. So point number 0 looks at the code. It says, okay, if my point number is 0, well, lucky me, I'm 0, so my point number is 0. So, okay, I can do the thing. All right, you want me to add a point? Sure, did it. Bingo. Here it is down here. All right, and then point number 1, it read this line of code and it said, hey, if your point number is equal to 0, and point number 1 was like, oh man, my point number is not 0. Okay, I guess I don't get to join the party. I don't get to do this line of code, right? That's kind of how we use if statements to control the flow of our code. So that prevents these other points from kind of creating points in this position of their own. So that's one way you could do it. Another way, and again, just using point 0 isn't like, I could do like 5, for example, and I would get the exact same thing. Because basically 0, 1, 2, 3, and 4 would all be like, oh man, my point number is not 5, I didn't get invited to the party. But point number 5 looks at their point number attribute and it says, ooh, I'm the winner. I am point number 5. I get to go ahead and run my code. So that's why this works. But the other way you could do it, which is probably even more straightforward, and straightforward is good, um, is you could just say, hey, we could literally tell it to only um, run if your point number is 0. So if I put 0 here, it's basically like saying if your point number is 0. This kind of is like a way of grouping it here. Um, so notice that without this, watch this number right here, this 25. So without it, right, I get a bunch of points that are stacked on top of each other. And as soon as I change it to 0, we only get one new point again. So that's kind of, I know it's kind of a little bit of a long-winded example, but it's really important to kind of understand that fundamental concept of VEX, which is the parallelism, right? The parallel nature of VEX, where every single point is kind of looking at this code and running it. So I mentioned it because sometimes you can use the AddPoint function and you can add a bunch of extra points to your geometry, and you're like, why is there so many points here? I definitely did not mean to add all these. And a lot of times it's usually because of something like this. But the thing is, in this case, we're fighting the parallelism of VEX, but most of the time the parallelism of VEX is actually kind of what gives it its power. So, for example, we could use parallelism to our advantage. We could say, instead of making a point at this very specific position, we could say, hey, go ahead and take your current position, right, wherever you are, and we can access that with the position attribute, right, which was @p, and let's go ahead and add a vector to that, and the vector that we're going to add is 0, 5, 0. So we're going to add 0 to the X channel, 5 to the Y, and 0 to the Z if you're European, Z if you're in America. So now, what that did was every single point took its own position and then it added 5 to it, and that's where it created the new point. So notice that each point has its new friend that it made floating 5 units above it. So that's pretty cool. We created a whole bunch of new points with only one line of code. Pretty amazing. I don't know why I sound like a 90s public access television education channel right there, but I'll try not to do that voice again. So this kind of opens up lots of different possibilities. I mean, for example, what if we do, let's take the points normal, and what we'll do is we'll take the position of each point and we'll add to it the normal times 4. And let's see. That didn't seem to work exactly how I wanted it to, and I believe that's because I don't have normals on this geometry. Let's check. Yeah. So I don't have normals on this geometry. So what I'm going to do is I'm going to create them here. So I'm going to go, there's lots of different ways you can create normals. I think one of the easiest ones that I actually like is actually using a wrangle node. And what's really cool is if you just type @n equals @n, it will literally go ahead and create those normals for you, which is really sweet. So again, I'm just creating normals with a single line of VEX. You know, to not complicate it too much, we'll maybe just go ahead and do normals with a normal SOP, just to kind of minimize the amount of VEX that we're using here. But we'll go ahead and we'll do point normals, and this is all kind of fine. So now if I turn on my normals, you can see now these points have their normals. So now that I have a normal attribute, I can show you here. So now it worked. Now the thing that's interesting about this is you might be saying, well, what's the point of using normal? I mean, we could just add 4 to the position in the Y channel and we get the same thing, right? Yeah, that's true, but what if we weren't using a grid? What if we were using, like, for example, a sphere? Let's go, let's do this, and that comes with normals. So I think what I'm going to do is I'm going to go ahead and make a switch here. And so we have, so now, if I go ahead and switch this to 1, we'll switch to the sphere. And now we've got a pretty cool thing going on here, because what we've basically done, actually I'm going to do this, I'm going to do, let's see, if I do the same trick where I add, but then yeah, so that, I think that may have gotten rid of the normals. Interesting that it kept it here. Maybe if I do, okay, so that should work now. Yeah. So here, if I had used the other thing where I'm just gonna add 4 to the Y channel. If I just do that, then I basically just created like essentially a kind of a copy of this sphere up here. But what I actually want to do is go ahead and add another sphere in the direction of the normal. So now, because my points were pointing outwards, that's the direction that each point made its new point in. You see, so that's pretty useful. You can kind of see, like, you start to kind of see the power here. I mean, I started with this and I created these points with one line of code. That's pretty sweet. Imagine trying to do this, like, for example, I don't even know, like, if I was doing it in Maya, I guess I would, like, copy the sphere and then scale it up and then delete the polygon, so you only have the points, right? That's a lot more like clicking around and stuff, whereas like with just one simple line of code, we were able to kind of get this new shape going. So now, now the idea is, let's go ahead and use the power of for loops to do this several times. So remember, for a for loop, you're going to need a kind of a counter variable, which we usually say int I equals 0. We need to know when to stop, so we'll say when I is less than, I'll do less than 5. So if we think about this, the counter variable is going to start at 0, and then if we do I plus plus, just to kind of complete the syntax, and then I'll plug this in here. Oops. Something is going on here. I'll debug this in a second, but basically, let's see. Let's see. For int. So I'm making an integer I starting at 0, and I'm saying when I is less than. So stop when I is less than 5. Or if, let's see, I think this is the right syntax. I'll have to investigate here. Oh, I know what's going on. I'm basically just repeating it a whole bunch of times and stacking a whole bunch of points like on these things. So I actually want it to go in increments. So what I'll do is I'll go ahead and multiply. I could multiply by the I value, but the problem with that is that's like a bit extreme from what I wanted. So I'm going to actually do I times 0.01, just to kind of dampen that down. I don't want it to be so extreme. And of course I just broke everything. Yeah, missing a parentheses. Okay, so now we've got something pretty cool here. So now, if I turn off the normals and I kind of zoom in here, let's do this. Let's start by just running the loop once. So we'll do less than 1. Or actually, let's see, less than 2. So what happened? So we created an integer I at 0, and we're saying, hey, every time you go through the for loop, go ahead and add 1 to that counter variable I. And you know what? When I is up until when I is less than 2. If I is ever not less than 2, then go ahead and stop the loop. So first thing that happens is I is 0. Hey, we're less than 2. Let's go ahead and run the loop. So what do we do? Okay, well, each of my original points, if I go back to kind of my original points, right? So these are my original points. Every single point, right, is going to be like, okay, you want me to add a point? That's fine, I can do that. What geo handle do you want me to add it to? Which geometry stream? Stream 0, that's fine, that's pretty standard stuff. And then now, each point saying, oh, I got some spicy calculations here. You want me to take my position, then you want me to add in the direction of my normal 3 times, it would be 0 here because remember I is 0 the first time around, so the first point would be 3 units in the direction of the normal from my current position. Okay? So that's basically what's going on here. So if I kind of switch back to this, let's just focus on this point right here. So this point, its normal's pointing this direction, and the first time I run through the loop, it's basically adding a point a little bit ahead in that direction. So that's kind of how you get this thing. And now if I just run the loop more times, like let's say I run it 8, or it'll be, yeah, 8 times, or I think it'd be 7 actually. But again, because we're starting at 0 and stopping when it's less than 8, so that'd be 0, 1, 2, 3, 4, 5, 6, 7. So I counted on my fingers, you couldn't see, but I'm actually holding up 8 fingers right now. So what's happening is, as I is getting bigger as it's going through the for loop, right, this amount that we're adding the point in the direction of the normal is getting bigger a little bit at a time, right? So here was the first time the loop went through, here was the second time, the third, the fourth, fifth, sixth, 7. I guess it is only 7 times. But anyway, you can kind of play around with this stuff. So one thing you can do is you could do like less than and equal to. If you know, for loops, to be honest, the way, like, some people start at 1 and some people start at 0. It's kind of up to you. It's just get whatever set of conditionals you put in here that make it run the amount of times that you want it to run, is what you should do, basically. That's a little confusing, but basically I'm just trying to say that if your for loop doesn't look exactly like mine because you use some other way of kind of like keeping track of this stuff, like let's say you like to start at 1 and then you like to stop when it's less than or equal to like for example 5. 1, 2, 3, 4, 5. This might make more sense to some people because they're saying, oh, I want to run the loop 5 times, and that's when that is, right? Whereas if I start at 0 and I stop at 4, that ran the loop 3 times, right? Because this is what we originally started with, and we had 1, 2, 3. So starting at 0, ending at 4, the loop ran 3 times. That can be sometimes kind of confusing to people. So I kind of learned this way, so you'll tend to see me kind of start at 0 and then put a less than and then a number. But anyway, all of that is to say that we've created a for loop that will keep adding points in the direction that we want. And this could be super helpful because if you think about it, like we could like create like tails to our geometry with this sort of thing. Um, we could, I mean, there's all sorts of cool applications for this. Um, but that's how to add points. And so we'll stop there for this video, and then in the next video we'll talk about adding lines, trying to maybe connect some of these points. So that's it for this video.